Humans look at the stars in the sky and wonder about the mysteries of the universe. How far can we see with a super powerful telescope? Can we see the edge of the universe? Will there be a wall there, and what is beyond the wall? These questions may sound silly, but these puzzles have haunted humans on Earth for hundreds of years. Humans decided to build a super telescope just to see what is hidden behind the twinkling starlight. The Hubble Space Telescope, HST, is the largest space observatory ever built. It brought humanity into the mysterious depths of the universe for the first time. Hubble has two aspects that we never knew: the sharpness of observation and the sophistication of technology. To understand this, we must start from the beginning. In 1946, astronomer Lyman Spitzer, known for his studies on star formation, published a paper entitled "Astronomical Advantages of an Extraterrestrial Observatory." The essence of the paper was to build an extraterrestrial astronomical telescope. Although people felt this was a bit fantastic, there were two clear and comprehensive points of view in the paper. First, space can eliminate the interference of the Earth's atmosphere to starlight. Second, it can observe infrared and ultraviolet wavelengths absorbed by the atmosphere, meaning that the capabilities of space telescopes will far exceed those of ground-based telescopes and will become real eyes of the sky. Let's go back in time to 1968. The National Aeronautics and Space Administration, NASA, finally decided to build a 3-meter diameter reflector telescope in space after a long debate. However, this project was repeatedly delayed. One reason was that the technology was too difficult, and the second was that the budget was too high. So the actual project had to wait 10 years later, or in 1978. Congress finally approved the project, but required the diameter of the telescope from the original 3 meters to be reduced to 2.4 meters. Don't underestimate this 0.6 meters, because it can save almost half the cost. In 1979, Perkin-Elmer, an optoelectronic technology company, began making space telescopes. The most important optical component, the lens, they use a very complicated electronically controlled polishing machine to polish the lens. Lens polishing continued from 1979 to May 1981. Because the technology was too complicated, the polishing progress was far behind schedule. In addition, the telescope itself, which was difficult to manufacture, also had to consider how to use the space shuttle to send such a giant object into space, while ensuring that its various components would not be damaged under strong vibrations. This was also what drained the brains of scientists at that time. The Lockheed aircraft manufacturer was also far behind schedule in transforming the spacecraft, so NASA was forced to postpone the launch schedule of the Space Telescope again. After a 5-year delay, the telescope and spacecraft were finally successfully combined. This unprecedented space telescope was named Hubble in memory of astronomer Edwin Hubble, who discovered the red shift that gave strong support to the Big Bang theory. At that time, everything was ready, just waiting for the time, and the Hubble telescope was scheduled to be launched in October 1986. Astronomy lovers around the world were looking forward to this moment. But unfortunately, expectations did not go as expected. On January 28, 1986, this was a sad day in the history of world aerospace. The Space Shuttle Challenger suddenly exploded 73 seconds after takeoff, killing all 7 astronauts. The accident stopped all projects scheduled to be launched using the space shuttle, including the Hubble Space Telescope. Its components had to be stored in a dust-free space in a different category, and the time for relaunching was still indefinite. The astronauts who were originally scheduled to install the Hubble telescope in space were forced to practice repeatedly in the water. This training was mainly to simulate the gravity-free environment in space. Although there is gravity in the water, it is much smaller than on the Earth's surface. About 3 years later, on April 24, 1990, the moment to relaunch the Hubble telescope finally arrived. Accompanied by the roar of fire, the Space Shuttle Discovery carried Hubble into space 640 kilometers from the Earth's surface. From April 24th to 29th, 5 astronomers successfully installed the telescope with a primary mirror 2.4 meters high, about 16 meters long, and weighing about 11 tons in space. It was 46 years since Spitzer proposed the concept of a space telescope until Hubble was finally put into orbit on May 20th, 1990. Hubble targeted the open star cluster NGC 3532. The gyroscope was activated, taking pictures with stable focus, and then sending its first images back to Earth. However, scientists were surprised to find that Hubble did not seem to achieve the expected observation effect. Subsequently, image after image was sent to Earth, but people were increasingly disappointed because the images sent by Hubble looked blurry and unclear. Some of them even had strange halos, indicating that there was something wrong with Hubble, such as having myopia and not being able to see clearly at all. After further investigation, scientists finally found the cause. The problem lay in the primary mirror made by Perkin-Elmer. Scientists found that the lens on the telescope shifted by 1/50th the thickness of a human hair. This small error made Hubble's observation ability 20 times lower than previously designed. NASA scientists tried to find a solution. If it was impossible for astronauts to replace the 2.4-meter primary mirror in space, then there was only one way, namely by adding a new camera to correct the error in the primary lens. In December 1993, when Hubble had been in orbit for 3 years, the first repair mission was officially carried out. This was a very complicated installation task with the aim of correcting a 2-micron error, a task that is difficult to complete on Earth, let alone in space where there is no gravity at all. To complete this repair, the astronauts underwent another 11 months of grueling training in a pool facing a replica of Hubble. This was also a mission that could not fail. If it failed again, Congress and the public would lose confidence in NASA, and there would be no more additional funding for Hubble. Thus, the Hubble Space Telescope would be a complete failure. From December 2nd to 13, 1993, 7 astronauts experienced an unforgettable journey in space. Because the precision was too high and very difficult to understand, they could only do the debugging process repeatedly, correcting and tapping again, and correcting again. Finally, after 10 days of repairs, the repair work on the Hubble telescope was completed. In January 1994, anxious astronomers pointed Hubble at Messier 87, the largest and brightest galaxy in the Virgo galaxy cluster, to take the next photo. Hubble then sent the photo back to Earth. This is a beautiful, stunning photo. People could hardly believe their eyes when they saw the photo. This is a magnificent spiral galaxy, about 55 million light-years from Earth, with a diameter of about 170,000 light-years, 60% of the size of the Milky Way. In the image, the 2 spiral arches of Messier 87 appear closely together. The center of the galaxy in the middle shines brightly, containing hundreds of billions of stars burning like the sun. This photo looks so clear. There is no doubt that space telescopes are the only way for mankind to observe the universe, and Hubble finally succeeded. After the success of its mission, Hubble turned its attention to M87, an elliptical galaxy 50 million light-years from Earth. The core of this galaxy emits a very large jet of high-energy plasma, stretching 4,900 light-years away. What kind of material can emit such great energy? Hubble spent a lot of time to continue observing it. If you want to see it closer, you need to continue to extend the exposure time. After the exposure time is extended, we can see an unexpected phenomenon. Scientists have realized that at the heart of the galaxy, M87 is a giant black hole with a mass of 6.5 billion times that of the Sun. This black hole is pulling matter from all the galaxies that orbit it, faster and faster, until it eventually becomes like a tornado. So fast, the energy becomes too much to control, and the matter surrounding the black hole is thrown away. Scientists have also made another amazing discovery. They have found that there is a black hole in our own galaxy, the Milky Way. The giant black hole hidden at the center of the Milky Way is known as Sagittarius A. The Hubble Space Telescope is a key tool that allows us to better understand the universe. But this is just one of many surprising discoveries. Scientists continue to use Hubble to uncover other secrets hidden behind the veil of the universe. Today, our view of the cosmos is no longer the same, thanks to Hubble. It has helped answer many questions that have been lingering in the minds of humans, and has brought up even more new mysteries that challenge scientists to continue exploring deeper.